fourth in a series, and today we're going to be talking about voluntary observing ships. We've got great presentations and a wonderful panel lined up for you today, so I'm looking forward to learning and to hearing some great discussion and welcome questions. I am Jessica Snowden. I am the Deputy Director for the Global Ocean Monitoring and Observing Program within the National Oceanic and Atmospheric Administration. I'm sitting here in now sunny Silver Spring, Maryland. I am also representing the AtlantOS Program Steering Committee and Coordinating Group. So thank you all again, for being here today. And let me move on to some introductions for our first. Oh, no, wait, I'm getting ahead of myself. I need to go to Anne, who is going to talk to you about some process and what to expect next.
Yes, thank you, Jess. We just wanted to quickly go over some guidelines. One is, please enter any of your questions you have in the Q&A section. We're going to allow for a couple of questions to be asked right after the presentation, but we'll have a longer discussion session later after all presentations have been concluded. So please put them in there and I will read them out loud for the panelists to answer. We do offer an optional networking at the end. You do not have to attend, it's just optional. I will put the link in the chat box towards the end of this. And we're using WonderMe. Just to be advised, WonderMe does not work on Safari, so please use your Chrome or Firefox only. You will be asked to have a little icon and put your name in, and this is kind of how the platform looks. As people trickle in, you'll see those round little bubbles with faces in it, and you can go into a room together and then have individual one-on-one discussions, and everyone can join this little like white shaded room. So just so everyone knows how this looks like. Yeah, that's all I have for this part. So please go ahead and back to Jess.
Thank you. So let me introduce our first two presenters to start our program today. We have Darren Figursky and Martin Crump, who will be talking to us first. Darren Figursky is with the operations branch at the Ocean Prediction Center in the National Weather Service here in NOAA. Darren is responsible for the operational forecast and warning services for the high seas in the North Atlantic and North Pacific. And Darren became the chair of the WMO IOC Ship Observations Team in October of 2017. Martin joins us. He's here with the ship. He's as the ship coordinator at Ocean Ops, which was formerly JCOM Ops. Martin supports efforts of the Repeat Hydrography Program, Go Ship, and panels the ship observations team, including the voluntary observing ships and ships of opportunity. So their presentation today is titled Ship Observations Team, Voluntary Contributions to GOOS from Various Vessel Types. And I will hand it over to Darren and Martin.
Hey, Jessica, thank you very much. And it's great to be here today. Again, I'm Darren Figursky. I'm with the Ocean Prediction Center, NOAA, and chair of the Ship Observations Team. And Martin, whenever you're ready to queue up the presentation, we'll go ahead. We'll start with a little history of the voluntary observing ship scheme, and then we'll go into a few details about why it's important. And we'll talk a little bit more about the broader ship observations team. So Martin, you can go on the next slide, please. I appreciate that. And so a little bit of history about the voluntary observing ship scheme, and kind of going back into the 1800s, it can be traced to actually the first International Maritime Conference held in Brussels in 1853, where a couple of the gentlemen that you see here on the screen and others came together to try to really standardize observations that were being taken on ships all around the world. And they recognized at that conference that meteorological observations were very important for the safety of life at sea, as well as for climatological purposes. They developed a standard, but then Martin, if you go to the next slide, followed up with the first international conference on the safety of life at sea. This was in 1914, a couple of years after the sinking of the Titanic. And at this conference, they recognized the need to make it mandatory to have observations of ice, but they also listed several meteorological pieces of information that were very important on an optional basis for, again, safety of ship conditions. So again, transmission of ice was mandatory, med-obs were optional, but they were very important meteorological parameters that they noted. If you follow along to the next slide, Martin, then we get to 1929, where kind of the second SOLAS, the second Safety of Life at Sea Convention. This is where they really started to really emphasize meteorological observations being taken by vessels at a particular frequency, and also encouraging nations around the world to start providing information to ships of major hazards, issuing daily weather bulletins, making sure, again, that people were going to be safe there on the oceans, and understanding, again, the meteorological phenomena, getting those reports from ships. If you go on the next slide, Martin, we have that today, the IMO, the WMO, there's a circular out there, it's called 1293, that mentions that meteorological observations are recognized as being essential, again, for the safety of ships at sea, but it also notes the contributions that ships make, not just to operational meteorology, but also to our understanding of our global climate, our understanding of our ocean systems. And so if you go on to the next slide, Martin, what we see here is an example of an individual taking an observation or part of an observation from a vessel. If you get a chance to look at either this presentation, or if you do a search online on this teamwork on weather at sea, you get about a 3-minute video of a person taking observations and what the voluntary observing ship scheme really means to observations, globally, for situational awareness for meteorologists to issue warnings, also for the improvement of our numerical weather prediction model. So I'll encourage you to take a look at that. Martin, if you go on to the next slide, please. There's a couple of slides here that I show why VOS is so important. And on the left slide is a satellite, its left part of the slide is a satellite image of scatterometer data. That's wind data from satellites. They're polar orbiters that tend to go into kind of like these strips around the globe. The hotter the colors, the stronger the winds. But you can see that the satellite coverage doesn't cover the whole ocean off the eastern coast of the United States. There are quite a few gaps in which there aren't very many observations that are there. We want more observations to help fill in those gaps. And on the right, while it might be a little difficult to see for those that are watching this, there's a satellite image there of a cloud feature at the base of the comma, kind of in the left middle of that image, is a ship observation of 65 knots. This occurred in the North Atlantic a few years ago, about a few hundred miles southeast of Nova Scotia. 65 knot wind, hurricane force wind as reported from a vessel. Now, as a forecaster, we want the vessel to avoid this. We got into it. We're glad we got the report. On the lower right is the computer model guidance that we had at about the same time, showing a low pressure system to the southwest of that ship observation of 65 knots. What does that mean? Well, it means that the model actually had the low pressure center a little bit too far to the southwest, because if you look in the middle of the circle, rotating counterclockwise in the northern hemisphere, the winds, if the model was perfectly right, should have been from the southeast at a much lighter speed than what the ship reported it to be. So as a result of this observation forecast, we were able to make a warning issuance, very short fused one with virtually no lead time, but hopefully to help people understand what the weather was doing in its area. And oh, by the way, hoping then to improve models that we're going to run later on. Martin, if you can go to the next slide. The model guidance that we get, though, is largely is good, but it's definitely improved upon by the observations that we get. The more observations, the better. And in this case, again, another example of why VOS is so important, hurricane force wind event in the Gulf of Alaska, which had 40 foot or just a little over 12 meter seas associated with it. On the left side of the screen, we see a lot of vessel avoidance. This is a image taken from kind of like a marine traffic website. All the triangles are vessels. And you can see many vessels are getting out of harm's way. And so there's a lot of avoidance there in the Gulf of Alaska. There's still a couple of vessels, though, that are there. And so we know that from the observations we get, we want to make better forecasts. We also know we need to get better messaging. Things are gotten a lot better over the years with our computer model guidance, but the more observations we have, the better they can be, and we want them all. Martin, if you can go on to the next slide, please. Observations have also been noted as being very important, unfortunately, in some tragic events. And this is an example of a report from the United States Coast Guard taking after the El Faro sinking. And unfortunately, in this case, the vessel wasn't taking many observations. It wasn't aware sometimes of the protocols. It wasn't consistent in taking them. And it noted in this report that the lack of observations and the lack of consistency in taking those observations on that vessel had some unfortunate impacts. So again, reports around the world when we have events like this from the National Transportation Safety Board as well as the Coast Guard have recognized, again, the importance of observations. Martin, if you go on the next slide, please, I appreciate it. So here's an example of kind of the status of the Voluntary Observing Ship program and some of the challenges that we face. In 2020, even in a pandemic year, there were over 2.5 million observations that took place, increase of about 4% of stations, increase about 10% in OBS. Many of those are automated observations. Over the last few years, at least, if not several more, the number of ships participating has been steady at best. And we really rely on port meteorological officers. These are people that are parts of national meteorological and hydrological services that go out to vessels to recruit them, to make sure their instrumentation is calibrated, to give them any paperwork, to help answer any questions that they have, to help with quality control and getting the metadata. These people are vital to making sure that we help get these observations. And so you see in the lower right, the observations around the world. If you think of the hot colors, the reds and the pinks, those are where there really aren't that many observations for the most part. The yellows and the oranges, it might not be quite so bad, but it's still kind of bad. The blues and the greens are getting better. And it'll even note the blue in those grids, that's about 26 to 200 a month. So even where you see a blue grid there, that could mean that blue grid is basically one observation a month. So the number of ships, again, is steady. We need port meteorological officers to help recruit ships, to help make sure the observations are flowing through. But we also need to look ahead at new ways to try to get that observational data from vessels. Martin, if you can go to the next slide, please. So we're forward looking kind of in an ocean decade. I think 2021 to 2030 is a UN ocean decade of ocean science for sustainable development. And on the left side, we see an example of observations. You can see the contrast over land, all the green spots, with the buoy observations in orange and the ship observations in blue. This was taken from my workstation at the National Weather Service about a month ago. And the number of blue observations, that was a good quantity. This is about 14 UTC, I think, on April the 8th. We're looking at different ways that we can also complement what we have from port meteorological officers working with voluntary observing ships. Could we start to get observations through AIS, automatic identification systems, which is meant for collision avoidance, but they also have the capability to send messages. Also, many of our counterparts in industry are taking observations, grabbing them in various ways. The data is varied, but there's technology that's being worked on to take all those varied formats, be able to provide them one system through which then we might be able to get those observations to the forecaster. Martin, if you hit the next slide, across the world, this is the kind of a map from shipmap.org. This is back from 2012, but it's a sample of all the AIS data that's out there from ships, and all those white spots represent vessels. And it's a goal, hopefully, through maybe an independent class or third-party class to involve more citizen science in the future, to be able to, again, to complement what we get from the traditional VOS program, to get more observations of the forecaster, improve safety of life at sea, improve our numerical weather prediction. Martin, if you can go on the next slide, please. But ship observations, just want to note, are more than just weather. As I mentioned earlier on, they help us understand our changing climate. They help us understand air-sea interactions, near-ocean surface variability. And I was just on a call this morning from one of our modelers at the NOAA's National Weather Service Environmental Modeling Center, and the lack of observations of salinity, of ocean surface fluxes with the atmosphere really challenges numerical weather predictions. So more observations like those are very important. They also help us validate, help with calibration of satellite information. Martin, if you go on the next slide, please. So the ship observations team has a number of components. We have 2 panels, the Voluntary Observing Ship Scheme, which I've talked a lot about already. We also have the Ship of Opportunity program. And then we have the Automated Shipboard Aerological program. All of these support research. They support climate forecasting. They help improve numerical weather prediction. They help improve safety of life at sea. And we'll talk briefly about those now in the upcoming slides. So Mark, if you can go on the next slide, please. So let's talk about ASAP really quickly. It's basically upper air observations on a vessel. Most of these are done Northern Europe across to Canada, a few near Eastern Asia. And if you look on the map in the presentation here, there was a research effort, the Polar Stern, up in the high latitudes in the Arctic. They took quite a few observations in 2020. Right now, there are about 20 ships that host ASAP stations. Most are done in the Northern Atlantic, but they really help, again, help with understanding of the upper levels of the atmosphere across the oceans where we don't have a lot of sensing devices to do that. So they're a very important part of our observational network. If you go on to the next slide, Martin, we'll talk a little bit about the Ship of Opportunity program. And it's more than just XBTs. I mean, the expendable bathythermographs are very, very important piece of information to understand the ocean temperature. But there's also thermosalinographs, there's plankton recorders, there's partial carbon dioxide, all these things, again, that help us to help improve our computer modeling, help understand our changing oceans, help understand our changing climate. And I wanted to point out that it was in the SOT program last year that really was hit hard by the pandemic. I think there was a 50% data reduction in XBTs globally. There was a 30% data reduction in PCO2 measurements. And, those are all due to the challenges of COVID. So that was hit particularly hard. Fortunately, some of my notes here indicate that about 50% of the XBT lines that were initially halted were able to come back in some form during the year. But note that the information that comes from Ship of Opportunity, are quite critical. Go on to the next slide, please, Martin.
That's for me.
And now I'll turn it over to you for ship coordination.
Yes, thank you, Darren. So until now, we spoke about basically about the voluntary observing ships, but also about the other panels of the SOT. I want to look even at the broader picture, and I want to stress that whatever we do when we observe the ocean, for in situ observations, we need support from ships, and that is much related with the work I do to better exploit synergies between the different networks in need of ship support. So beyond the SOT, of course, for research cruises, we need ships. We need ships to maintain moorings, to deploy autonomous instruments like floats and drifters. And we can do a much better job if we better coordinate all these efforts. And this is what we do at Ocean Ops, actually. And it has happened in the past that the container ship comes to port, will stay there for a few hours. And within 3 hours, 3 different persons show up and say, hello, my name is, I don't know, Darren, I want to deploy a drifter. Then it comes Martin and says, I want to install an underway system. And then comes Henry and says, I want to install a weather station. All 3 of them say they don't have money, they don't have budget, they require volunteer contributions. And the ship officers, they will at the stage not understand that, why we say we have no money and we send there 3 persons, and the 3 persons do not even know each other. So we in Ocean Ops, we coordinate between these networks and help to exploit these synergies. To do that better, we need metadata from all contributors and from all operators of such instruments. And this is my take-home message for you. If you are involved in such operations, please let us know about it, submit us this information. In Ocean Ops, which is a WMO IOC Center for Monitoring, Implementation, Support, and Coordination of the Global Ocean Observing System, we produce products like what you see here. You see it is one ocean. There are not multiple oceans. It is really one ocean. What you see nicely on the left in the Spillhouse projection with those around 8,000 stations and platforms, which are at sea at the moment. On the right-hand side, at the top, you see all the blue dots. This is where we have in the month of December last year, every blue dot is a voluntary ship observation to the VOS program. And as you can imagine from the other map we showed before, the Southern Hemisphere is not so well covered. You see the red and green lines. This is the status of the XBT lines, which are repeatedly sampled every 3 months or so, some of them ideally monthly. And you see the red lines, those are the lines which have not recovered yet from the COVID-19 impact. And additionally, you see in the Southern Ocean, you see a purple line. And this is actually an ocean race, yacht participating in an ocean race, which submitted weather observations and also deployed instruments at sea, and also gathered underway data, so salinity, PCO2, and all these things that Darren mentioned already. And you can certainly understand that having such one ship can make quite a difference. That ship will gather data for a few weeks only, but if they drop drifters and floats in these areas, that will be very beneficial for quite a while. Other products, like for the Argo area, you see at the bottom right. So we work much with the sailing community, because in these undersampled areas, they are quite often the only vessels which go there, and which go there far from the regular shipping routes. So you see some of our flagships here. You see Pangaea from Mike Horn, one of the well-known adventurers. You see Bark Europa, which the tall ship on the top right, which regularly sails from Europe around Antarctica and back. You see a racing yacht, which is holding the round the world record against the tide and wind at the top, at the bottom right. And you see in the middle, actually, an old traditional ship owned by Arvid Fuchs, which is an adventurer who will leave Germany in a few weeks and go in the Arctic, doing a lot of things, actually, having a weather station on board for VOS, but also sampling underway data for SOOP and deploying drifters. So these are somehow super ships of both opportunity and voluntary observing ships. They do not have an IMO number. That is why it was quite important that we find ways to identify these ships beyond the IMO number individually. We give certificates to participants of SOT programs. This is just one here for the ship in the middle, to recognize their efforts, so they have something which they can show on the bridge, or to their communities, which is with the labels of WMO and logos and IOC UNESCO on it, so that they get some recognition for the work they do. This one here signed by Henry Kletar, recently the chair of the VOS program, who cannot join us today. We submitted through OceanOps recently an application to the Ocean Decade, already mentioned by Darren. The Sailing for Science initiative plays an important role. You see here on the second picture, this is the complete route where we gathered data recently in 80 days of time. And this, in terms of outreach, of course, was in all the media, had a big success story with this. And we also involved in this Decade application other industry partners, like touristic cruise ships and so, or survey ships, which will help us get more data in undersampled areas. Then this here, I could already give it probably back to Darren. I will do it quickly. So if you want to learn more of the VOS program, there is the VOS poster, which we have, and the VOS brochure. It still says here JCOM, which is the former Joint Technical Commission of WM and IOC. Which does not exist anymore. So we will review this shortly. This is the best we have at the moment, but already on the last page is one page for the other ship related networks like SOOP and profiling floats, drifters, and so on. That said, I will say again, we need metadata from everybody who contributes to the ocean observing system to exploit synergies. So please let us know if you have stations at sea, if you know of ships which will sail from A to B, which could be useful for other persons to either deploy an instrument or to recover an instrument. All this information, please let us know about that through the OceanOps website. It's quite easy to do that. That's all from us. Thank you, and back to Darren and Anne from here. Thank you.
Anne, I think we'll turn it back to you for the next presentation.
Yes, thank you. I'm going to turn it over actually to Jess to introduce the next speaker.
Thank you. Thank you, Darren and Martin, for that. Just a quick comment personally before we move on. It's always amazing to me to look at, we've all seen them multiple times, all those maps of all the dots, and to be reminded of how just how undersampled and underobserved the oceans still are. I mean, those dots are just, to make them big enough to see, it just really misrepresents how undersampled things are. And the voluntary observing ships is just an amazing example of a creative way that the community has tried to fill those gaps one observation at a time. So thank you so much for that. Moving on to our next presentation, Axel Anderson is going to speak, and let me give a brief bio for him. Axel is the lead for the Deutsche Wetterdienst Marine Climate Data Center, Apart from the climate data management of marine meteorological observations and climate messages, he's responsible for the operation of the WMO IOC Voluntary Observing Ship Global Data Assembly Center, among other efforts. Axel's been active in several WMO IOC expert and task teams dealing with international data management with a focus on marine meteorological climate data. And so his presentation to us today is going to discuss from weather to climate, data flows and applications of voluntary observing ship data. So Axel, over to you.
You're still on mute, Axel.
Yeah, sorry. So thank you for the introduction and mastering the hard acronyms. There will be some in my presentation. I will try to share my screen first. Yep. And put on my presentation. Okay. I hope it is on now. So, yeah, I am with the Deutsche Wetterdienst and responsible for the Marine Data Center or Marine Climate Data Center. We operate several data centers. We have the National Marine Data Archive, and we operate the Voluntary Observing Ship Global Data Assembly Center, and I will explain to you later what it is. The title here, From Weather to Climate, Data Flows and Applications of VOS Data, it should give you, for those who are not so familiar with all the data flows, the data flows that we have from a perspective of the Met service, so data that we can access as a Met service from voluntary observing ships. There are two main applications. We have real-time data. I have this here under the point weather, and then we have, we call it delayed mode data, which I will put under the point climate. Of course, these interact, these points, weather and climate are not independent of each other, and the data uses are not independent of each other. There are other data sources. Martin already showed some initiatives to extend our data sources that we can integrate into the systems, and I hope we can discuss about that after the presentations. One remark, in most cases, VOS data will not be used alone. So we always need, because we have data voiced areas, we have perhaps just not the temporal coverage of by VOS data. We will often use VOS data in synergy with other observations. So particularly for example, SST, there's a strong synergy between satellites, buoys, and VOS data. So this is a remark, and you should always keep that in mind. So first, I will start with the real-time data flow. So we saw many observations and how the observations are gathered on a ship, and how does the weather service receive these observations. So first, we have the observations here, which are either made by hand, and this is important because by hand and by eye, you can observe weather phenomena, you can observe clouds, which is not possible, at least not in a good quality as we would like to have it, from an automated system. What you see here on the top left, is just a box that we can screw on a ship, and this is fully automatic, and no one on board of a ship has to do something with it. Just in some cases, see if there is a need for maintenance, and then ask the PMO to repair it. So we have the voluntary observing ships, which are equipped in most cases by weather services or other agencies, and they do the observations. And the observations are continuously transmitted to land stations via satellite or other telecommunication systems, and then they are fed into the global telecommunication system, which is the system used by the weather services to exchange meteorological and other data on a real-time basis for the daily operational work. So this data is then received by the national agencies. Often they have a nice big computer, and then they run the models in there. And we have lots of applications of data and model output. Darren showed some of the applications already, which are like weather forecast. We have warnings, issues. Important is nowcasting to fill the gaps by the weather models, by the satellite data, and of course the applications in ship routing, and many more. For weather service in the real-time domain, this is the end of the use of the data. We have to do other services, and new services, new weather forecasts are going to be produced. So we get the next data ingestion from the operational weather observations. So if you want to use the data later and want to use it for climate, there's in particularly for the VOS data, a well-established system that we call the delayed mode data flow. So the goal here is to have a long-term preservation and long-term availability of the observations. And also we want to have a quality control on the data. So we have a level of quality and consolidation for the data so that we can use it later on, in particular, for example, for climate studies. So this was already the original purpose of this system. So in former times, there were regular climate summaries produced by several Met services, and each Met service was responsible for an ocean area. In these times, when you have all your data available on a computer, data processing works much more in a much more productive way, so that this system is not needed anymore. But of course, quality controlled climate products are still available. Another important point is that we have enhanced metadata associated with the data. And here comes the connection to OceanOps, which is keeping the metadata, and we rely on them, that they have good metadata that we can use and link to the data so that we have good information about the data that we have in the climate archives. One important difference between the fully automated data flow in the GTS is that we have here quite some manual data preparation and manual interaction in the data exchange. On the other hand, the data is not restricted to GTS. So data is submitted into this delayed mode in the delayed mode, which might not be on the GTS. So we receive data which is on vessels like Martin showed, which were going on expeditions, and later submit the data after they come home, and they submit it and in the delayed mode data system. This system is existing, as Darren showed, basically since the 19th century, where ship observations were routinely collected and already then internationally exchanged. Today, we exchange the marine climate data through the formalized system of WMO and IOC, the so-called Marine Climate Data System. This is a system that has been recently set up. It is not only restricted to VOS data, but it is a basic scheme how to exchange and how to collect and gather marine climate data and make it available to the public in a formalized way, so that we have standardized QC information, metadata information, and we can use it for climate application, and we have transparency from the data production to the end product. I will quickly go through this, what this means for VOS data. So in the first step, we have a data acquisition center. This is the agency, the PMO, the Port Meteorological Officer, that collects the data. And typically, this data
I think we might have lost Axel. I'm going to give it 1 minute just to see if it reconnects again. But I think it was starting to there we go.
is failing.
Okay, Axel, we lost there for a second.
Sorry?
We lost you there for a second, so we didn't hear. We lost you for a second.
Oh,
We
okay.
didn't hear the last like 30 seconds.
30 seconds. I will go back to the data acquisition centers. Yeah, it just showed up here that the connection is not stable. So I will quickly go through here. So the data flow starts with the data acquisition center. The data acquisition center is typically the meteorological service or the PMO who collects data in an offline mode from the ships. Routinely, ships are visited by PMOs and for maintenance, and then the data is gathered offline, or the data is gathered from the databases from the service. A basic QC is applied, and then the data is forwarded or supplied manually to the VOS GDAC, the Global Data Assembly Center. So the Global Data Assembly Centers are currently existing of two. For the VOS, we have two Global Data Assembly Centers. One is operated by DWD, and the other one is operated by the UK Met Office. Both basically do the same tasks to have a fail-safe operation. If for any reason one of the centers is not able to provide the data, the other one can take over. So both centers collect and consolidated the international VOS data contributions. They do a basic QC and they check if the QC has been applied. Consolidation is done in terms of sorting out duplicates. And then the data are publicly accessible on the internet through the German GISC, which is the WMO connected to the WMO information system, and in a predefined format, so everyone can read the data and download it for free. And anyone can submit the data. You can register through the system, and here is the website from the German VOS GDAC. When you click on the link, you will land on the German side, but you can switch to English. And if you're interested, you can contact us via mail. So the DWD address is here, and the GDAC from the Met Office is accessible through the other email address. In the end, we have an international initiative where we collect all kinds of marine meteorological data, which is the IQuartz data set. Some of you may know that. This would take in the scheme the role of a so-called CMOC. It is not formalized yet, but in the end, the CMOC has the role of aggregating sources from different GDACs, and combining them into a combined data set, and also producing basic climatological products. One other important data source are historical observations. So this goes back right to the beginning of Darren's presentation, where he started in 1853, where many countries around the world agreed on a formalized way to collect data. On the right-hand side, you see a view to our archive here in Hamburg, where we have a great collection, large collection of original historic ship logs. So the collection here starts in 1868, and you can see down there a page from a logbook, and it basically contains all the observations that are made today. These observations are digitized and also fed into modern data archives like IQuartz. So they go side by side with the modern observations, and we have a record from now back to the mid of the 19th century, and even going back further for individual voyages of ships all around the world. So observations made a long time ago are still very important for understanding of weather and climate, and any observation made now is in the future also very important for the understanding of weather and climate. So I just put a quick list of related applications, climate-related applications of VOS data. Darren already mentioned some of them. So we have basic climatological analysis and data products of all kinds of applications here. Climate monitoring. So if you want to monitor the state of the climate, VOS data are important input. case studies. Darren already also showed case study with the, for the one ship. Yeah, and validation and calibration of satellite data is an important use, which is, and then the input for reanalysis models. So we use the data to feed models, and we can analyze the climate and the weather up to 100 years ago and even further back. And there are many applications, and not all of them are listed here, and some also overlap with the real-time data mode. Okay, so as a summary, a VOS observation can have many lives as a data source for a large variety of applications. So the first application is that we have it in the real-time data, so the weather domain, and then we have a delayed mode or climate application, and you saw that you can either submit them to the GDAX, or even data is rescued that you recorded 100 years ago, or your colleagues, your former colleagues, and we now use the data. What we need is we need integration of new and unexplored data contributions. Either you register your service with the VOS GDAX, register as a DAC. We have initiatives like the OpenGTS, and what Martin just showed, there was this Ocean Decade Odyssey application. Okay, and this is a run through the different data flows and the applications from my side, and I thank you very much for your attention, and hope we have a lively discussion now. Thank you. Okay, how can I stop it? Yeah.
Yes, thank you, Axel. So we have a little bit of time left to have our panel discussion. So I'm going to hand it over to Jess, who is going to quickly introduce the panelists that are joining today, and then we're going to go right into the question session. So if you have any questions at this point, please feel free to put it either in the chat or better in the Q&A section, and I'll make sure that we'll answer them.
Thank you so much. So in addition to our previous three presenters, we have the following folks joining us today for the panel. We have Francis Bringus, who is with the Atlantic Oceanographic and Meteorological Laboratory at NOAA, Champika Galaj, who is Scientific Officer, Earth System Monitoring Division with the World Meteorological Organization, and Tamron Morris, who is Marine Coordinator at South African Weather Service. Just as a programming note, as advertised, Dr. Soren Gutekunst is not joining us today because he is welcoming, along with his partner, his first baby into the world. So I suppose that's a reasonable excuse. I will pass this back to Anne and the panel, and welcome everybody's questions.
Thank you so much, Jess, and thanks everyone for being here. I have posed two questions to the panel that I'm just going to start out with to give the participants some time to ask their questions. And so the two were, how do we use data collection through VOS, and how can we increase the socioeconomic impacts of VOS and the larger SOT networks and beyond? I have some other questions that I have for the speakers and panelists, but maybe we'll bounce those questions to the additional panelists today and start with them if they have any insights that you want to share with the broader community, either on the presentation, what we talked about today, or any of those questions I had posed previously.
So if you wish, I can go first. And yeah, to give a WMO perspective. As many of you know, that WMO is dedicated to international cooperation, coordination, and also on weather, climate, and water-related activities. So with Earth system monitoring approach at WMO, VOS, and also all the other ocean observing platforms provide very important data required for Earth system monitoring. So with the WMO telecommunication system that Axel already mentioned, it provides the pathway for the observation systems to share the operational observations which are time critical for the services. The WMO information system, which we call VOS, it also facilitates the free and unrestricted access to information, which provide the products and services on matters related to the safety and security of the society, the economic welfare, and the protection of the environment. So the data from VOS, either in real time or in delayed mode, is quite important for a number of areas that we have already heard to provide accurate forecasts for climate services and research and others, which in turn provide information for social benefits, protection of environment, and also economic welfare. On top of that, under the SOLAS Convention, WMO, together with other two international organizations, the International Maritime Organization, IMO, and International Hydrographic Organization, IHO, they ensures the ships has automatic access to maritime safety information, including navigational warnings, meteorological warnings, and forecast through WMO and IMO mechanisms. So WMO and IMO together collectively provide those services for the safety and security at sea and the protection of the marine environment. So you can see there's large number of uses of the VOS data, which provides the societal benefits and the safety of life at sea and the economical aspects. So that's what I can provide on my side.
Thank you so much, Chandrika. Tammy, you unmuted yourself, but I wasn't sure if you wanted to add anything.
What do I want to add? We actually hosted the 9th session of the Ship Observations team when we all come together biannual meeting at IMO in London to bring the IMO in better contact with our community, which was not so well established as one could think. And with ideas like, why shouldn't we, per IMO regulation, say every ship at sea, every professional ship should be equipped with a weather station, and like they must submit for safety reasons AIS data to avoid collisions, they should also submit weather observations so that we can make navigation safer and more economic also, because it has some impact on fuel consumption. But the feedback we had is, if we do not have a number of member states of IMO coming with a very strong voice, this will not pass on IMO's side. So we have certainly very good ideas how to get more observations and how also to get more observations, in particular from these undersampled areas. But there is, through the international organizations, quite some way to go until this really happens. But we won't give up. We raise it frequently.
So just building on to what Martin said, but also if you think back to the map that he showed of the observations that occur globally, you'll remember that, or I think Darren showed the map, there's a large number of observations in the North Atlantic, and a lot of the Southern Hemisphere is severely understudied. And for a lot of the global forecast models, it's really only those observations that are coming from the ships of opportunity that are assisting forecast or being assimilated into models and assisting the forecasters in the Southern Hemisphere countries to be able to give accurate weather forecasts. So, you know, in the understudied areas or under-observed areas, we really rely on those observations, and the more ships we can have doing them, the better.
I can happily take the questions which I just saw in the chat pop up. Because
I was about to jump over to questions because we have a couple coming in. One of them was, what is the possible role for new observing systems such as sail drone and fulfilling gaps perhaps, but thinking of costs? Are there any ways to spend money if we had some to best improve the sampling?
So I can take this one, but I don't want to monopolize the floor here. I actually just received the first metadata from sail drones as part of the VOS program. And we had a discussion on this in a workshop yesterday, actually. because the role of sail drones is not so clear. We do not put them under the umbrella of one particular network at the moment, because it could happen that in the future that a sail drone will just host like a weather station for one institute and a thermoselenograph for another institute, and so equipment on board which is under the responsibility of different people. So for me, we should deal with the sail drone rather like with a ship, like a hull, which hosts equipments, and then see where these instrument packages really belong to. So if there's a weather station on board, that would be part of the voluntary observing ship scheme then. Yeah. I've received first metadata, so it is happening.
If I can add to that a little bit, when it comes to partnering with industry, we certainly want to do that. I think that there's going to be opportunities for some of these kind of partnerships, particularly to help in maybe targeted areas, Gulf Stream applications, maybe some hurricane genesis areas and the like. But the one thing to keep in mind that the ocean is vast. It's what 70-some% of the Earth's surface. So all of these types of platforms, I don't think are going to be able to cover all of that surface. So the partnerships are going to be important, but we're going to need, I think, some sort of independent class, I'll call it citizen science type initiatives, because there's a whole lot of regular ships out there that either don't report or are reporting in ways that the data is only getting into their own systems and not getting out to the broader community. Another challenge we have to face, and I see it's part of the question there, is to make sure that the data is fair. So from any entity, how are we going to be able to utilize the data? Can we share that data? Those are all things that are going to be involved with our use of of observational information coming from the private sources.
Thank you so much. And Pika, while you're raising your hand.
Yeah, just to add to this data question, I think that more and more we see that the data is coming from private entities, and even the med services tend to buy the data from private sector. So one thing to keep in mind is when you make the agreements with these private sector parties to buy the data, it's good to have them in a way that you can share it beyond your use, because that will help the global community to have more data by getting that data that is bought by someone, and you increase the value of data by doing so. So in WMO, we encourage the public-private partnership, and we have set up the guidelines for that. So I really would like to remind the service, the operational the community to keep that in mind when you are going for the private sector engagement. Thank you.
Thank you, Jessica. Handing it over to Francis, I think you unmuted yourself to comment as well.
Hi, I would like to add a quick example of what we have been talking about, combining different platforms to maximize the use of the observations. For example, at AOML, at NOAA AOML, we have been during the last few years developing a program to collect observations during the hurricane season. And we know that the best value from those observations is when we combine different platforms, different instruments, because each of them has its particular strength. And then when we combine them all, we get the most out of that data. And for example, this year we are planning to collect observations from XBT that we deploy from cargo ships in the Loop current, in the Florida current. But we are also planning to use that in a combination to observation from Argo floats, surface drifters, sail drones that were mentioned here, and also underwater gliders. Because we know when we combine the strength of all those platforms, we get the most out of the data.
Thank you so much. There were a couple more questions coming in the chat, and I would like to hand it over to Tammy to address the part how our commercial ships recruited into this program.
Thank you for the question. So we've got two initiatives at the moment through the VOS, through the SOT group as an overall entity, but also through the SOT panel, given the detail that's required in setting up an XPT system. And we are actually setting up best practices, standards of best practices at the moment on how to recruit vessels. This is done through the PMOs in each of the countries, but where countries don't have PMOs, you're welcome to contact the technical coordinators here on the panel who could probably help you with that. But we are developing ways in which people can interact with ships and find out what their capabilities are if they're wanting to be involved, and how to go about doing that and link up to the program. So those should be available hopefully soon through the best practices page and through the SOT pages.
Thank you, Tammy. Does anyone else want to comment on this? If not, we have many other questions. All right. Axel, do you want to say something?
Yeah, for the VOS, for weather observations, basically the same as Tammy said. First contact point would be your national service, who has a PMO and would provide the ships. Otherwise, go ahead and look at the VOS page, and there are contact addresses the VOS chair and the technical officers can provide you. And often it's just initiatives also from the meteorological services, from the services looking for ships and having contact with shipping agencies, and increasingly, of course, with other private partners.
Thank you. Another question that came in was, how are EEZs issues handled? And I think Martin wanted to take the first stab at this.
Yeah, so the VOS program has a very long history, actually longer than UNCLOS has, the law of the sea. And the question is, how do we define marine scientific research? What the VOS program does is in general not considered to be marine scientific research. And this is why we do not have real issues with EEZs through the VOS program. However, that is also why the VOS program pays so much attention not to add any parameters to what we do in the VOS scheme, which could create issues. So when we were asked to add, for example, depth measurements, for example, that was rejected because we would quickly get into an area which is grayer and grayer and grayer, and suddenly we are in something which is considered marine scientific research, and then we have the EEZ issue. And that is also why it is so important to make that difference between VOS and SOUP, which is also which has here its background, because in the SOUP program we certainly do something which must be considered as marine scientific research, and in the XPT program we actually at the moment deploy half of the expertise, so around 6,000 per year in a non-COVID year, inside of EEZs on a don't ask, don't tell basis. So for the VOS it's not a problem. For SOUP, even in particular, if you make more and more media activity, we certainly have to pay more and more attention, because there have been shipping companies already who are aware of that and who rejected or refused to continue these operations. But as in another step, WMO 2 years ago, I think it was, Champika, they passed there was a resolution which went through Congress, which underpinned that additional parameters, including subsurface parameters, are important for operational forecasting and for the safety of life at sea. So we somehow try to circumnavigate that issue to get possibilities to gather data more easy in these areas.
Champika, you have your hand up.
Yeah, just to add to what Martin has mentioned, WMO regulatory material specifically mention and request members to provide other members to take observations in their exclusive economic zones. And there are some gray areas, as Martin mentioned, that when it comes to physical atmospheric variables, we have no issues. But if we go beyond that to oceanographic variables, which has economical impacts and security impacts for the nations, then we need to go through the approval processes. And also WMO and IOC together are working on setting up some kind of easy process for the scientific community to get the EEZ observations, but that is in works, and there are some progress, and we hope that there will be more progress within the next couple of years. Thank you.
Shampika, will there be, sorry for the intervention, but will there be any improvements through the new WMO data policy that is currently on the way?
Data policy emphasizes members to support taking the observation within EEZ, but it is not a shall statement. It is a should statement. So there is still a little bit of leeway for the nations not to, yeah. So we will get there, but we have to navigate through really carefully, because national legislations are much, we have to respect the national legislations over the WMO regulations. So for that reason, the progress is slow.
Thank you, everyone. I know we're at the time right now, and it's 11:30. Sorry for cutting the panel discussion a little bit short. I will record the questions and make sure that the panelists receive them, and we can still follow up with you and answer those. The session is recorded, so if you know anyone who is interested in learning about VOS and beyond, please forward the link that I shared in the beginning in the chat with everyone. I wanted to thank all the speakers for your great presentations. I definitely learned a lot and understand this realm a lot better now. And I'm hoping that we can continue this conversation at some point. Jess, do you have any last remarks?
Just want to echo my thanks to all of the presenters, panelists, and for everyone who joined us today.
Yes, and thank you all for your time. If you want to join the WonderMe networking session, I did drop the link in the chat, so you're welcome to join that.
Thank you
very much.
Bye, thank you.
Thank you.